All right, welcome. Today, we're diving into a really cool type of database, one that is absolutely obsessed with one thing and one thing only, time. So, let's get right into it.
So, you're probably wondering, why can't we just use a regular old database for everything? I mean, we've got amazing databases already, right? They run our banks, our social media, everything. But here's the thing. They're built for transactions. What happens when your data isn't just one event, but a constant, never-ending stream of measurements?
Just think about it. You've got a server reporting its CPU usage every single second, a factory with thousands of sensors measuring temperature, financial markets spitting out millions of price updates. I mean, this isn't a trickle of data, it's a fire hose. And if you point that fire hose at a traditional database, well, it's going to start to buckle under the pressure of all those constant writes.
And this is exactly where we need a different kind of tool. Not a database that just puts up with this flood of data, but one that's been built from the ground up to actually thrive on it.
And that, my friends, is a time series database, or TSDB for short. It is totally purpose-built. Its entire design revolves around one single powerful idea. The timestamp isn't just another piece of data. It's the main event. It's the axis around which the entire universe of data spins.
Now this right here is the secret sauce. This is the core idea that makes these databases so incredibly fast. See, with time series data, you almost never go back and change something that happened in the past. You don't edit what the temperature was 5 minutes ago, you just add a new reading for what it is right now. This super simple append-only pattern is the key to their amazing write speed.
And the data itself, it has this beautifully simple structure. You've got the measurement, that's what you're tracking, like CPU usage. Then you have tags, which are basically just labels so you can filter things out, like which server are we talking about, which region. Then you have the field, which is the actual number you recorded, and of course, the most important part, the timestamp. That's pretty much it. So simple, but so powerful.
Okay, so that's the basic idea. But how on earth do they actually handle millions of data points a second without, breaking a sweat? Let's take a look inside the machine.
It really all boils down to 3 really clever engineering tricks that are just perfectly designed for time series data: how it's written, how it's compressed, and how it's organized on the disk.
So, first up, the write path. When a new data point comes flying in, a TSDB doesn't immediately try to write it to a slow disk. No way. Instead, it zips it into a super fast in-memory buffer. Then, once that buffer's got a nice big batch of data, it flushes the whole chunk to the disk in one go. Super efficient.
And this really gets to the core philosophy here. The database knows its #1 job is to grab that new data point as fast as humanly possible, because it also knows there's a million more right behind it. It is all about keeping up with that relentless data fire hose.
All right, next up, compression. So if you look at raw data from something like a temperature sensor, you can see the values are changing, but not by a whole lot. Storing the full value every single time is honestly pretty redundant.
This is where some really clever compression algorithms come into play. Instead of storing the full value every time, you can use techniques like delta encoding. You just store the starting value, and then you only store the difference, or the delta, from the point before it. I mean, just look at how much less information we need to store the exact same data. It's amazing.
And this works so well because time series data is usually pretty predictable. Your CPU usage doesn't just jump from 10% to 90% from one second to the next. And by storing only these tiny little changes, TSDBs can get these incredible compression ratios. This is a total game changer because it means you can store years and years of high-frequency data on a surprisingly small amount of disk space. That makes long-term analysis actually affordable.
And finally, let's talk about storage. A TSDB uses something called partitioning. The best way to think about it is like having a mailroom clerk who automatically sorts all the incoming mail into different boxes. And each box is labeled with a specific time range. A box for Monday, a box for Tuesday, and so on.
The benefit here is just massive. When you ask for data from, say, last Tuesday, the database doesn't have to scan through every single thing it's ever stored. Nope, it knows exactly which box, or partition, to go open. This makes queries for specific time ranges blazingly fast.
Okay, so we've got a database that's super fast at writing, super efficient at storing, and super quick at querying. But where do you actually find these things out in the wild? Well, turns out they're pretty much everywhere. Seriously, you will find them all over the place. They are the absolute backbone of DevOps monitoring, keeping track of server health.
They are essential for the Internet of Things, collecting data from millions of sensors. They power real-time financial trading platforms, and they help developers figure out how their apps are performing by tracking things like latency and error rates.
So, if you've ever looked at one of those slick, real-time dashboards showing server stats or website traffic, guess what? You've seen a TSDB in action. Tools like Grafana make the pretty visuals, but the TSDB is the powerhouse engine doing all the heavy lifting behind the scenes.
But, just like with any specialized tool, all of this incredible performance comes with some trade-offs. It's not a silver bullet for every problem. It's more like a precision instrument.
This table really lays it all out. A TSDB is a specialist, right? It's built for that constant stream of new data and queries based on time. A traditional relational database is more of a generalist. It's designed to handle complex relationships between data and lots of updates to existing data. They're just optimized for completely different jobs.
So yeah, the advantages are crystal clear. You get amazing performance for anything related to time, incredible storage efficiency, you can handle these massive data streams, and you even get helpful features like automatically deleting old data for you.
But what's the catch? What do you give up? Well, you lose the ability to easily do complex joins between different types of data. They're just not built for that rich relational modeling. And that whole append-only thing means they are absolutely the wrong tool for any app that needs to frequently update existing records.
So in the end, a time series database isn't better or worse than any other database. It's a specialist versus a Swiss Army knife. It's a tool that has been sharpened to perfection for one specific job, making sense of our world as it unfolds, moment by moment.
And that leaves us with a really fascinating thought. As our world gets more and more connected, with sensors in everything from our cars to our cities, the need to understand data over time is just going to explode. The question isn't if we can measure it anymore, but what new insights are we going to uncover next? Thanks for watching.